All right, here are solutions for perfect problem 1 for Math 65. We're given a system of linear equations and asked to find the solution actually 3 different ways. So hopefully we'll get the same answer using each of our 3 methods. And so really this is just a chance to show that you know how to do it in all these different ways. First one, find the solution by substitution. So the idea when you're substituting is you want to look at your 2 equations and pick the equation that has one of its 2 variables that's easy to solve for. I think what I'm going to do is pick equation 1 and solve for x because of this x right here. Now you could solve for y in equation 1 or x in equation 2 or y in equation 2. Really have a lot of options. But I like this 1x hanging out by itself here. I think that'll make things easy. So what I'm going to do is I'm going to take 4y plus x equals 2y plus 6 and isolate this x right here, solve for it. It's relatively easy. I just got to get rid of this 4y. So if I subtract 4y from both sides of the equation, 2y minus 4y leaves me with negative 2y. So in just one step, I've managed to take this first equation and solve it for one of its variables, x in this case. And now what I'm going to do, maybe I'll change colors, is take another equation, the other equation, 4 plus 4y plus 4x equals 7x minus 4. And everywhere I see an x, I'm going to replace it with this negative 2y plus 6. There's actually other ways you could do this. You could simplify this before you go substituting things in. It would probably make it a little bit easier. But just so that the solutions, if you know how to do that, you're probably not looking at these solutions. So maybe I'll make these solutions as straightforward as I can. And I won't simplify anything at this point. I'll just replace all the x's. So instead of plus 4x, I got plus 4 times this thing here, the negative 2y plus 6. And then over on the other side of the equation, I got 7x minus 4. But instead of x, I'm going to write this thing over here that I solved x for, that found out x was equal to, negative 2y plus 6. So what I have over here is a linear equation in one variable. Kind of a mess. There's a lot going on here, but there's no x's anymore. There's just numbers and y's. So what I can do is I can simplify this thing, solve for y, and then use that answer to come back over here and figure out what x is. So to simplify, I want to collect like terms. I want to get all the terms with y's in them together. It's kind of hard to move pieces around when you have these parentheses. So my first step is I'm going to get rid of these parentheses. Leave this 4 alone. Leave this 4y alone. But instead of 4 times negative 2y plus 6, I'm going to take this 4 and distribute it into the parentheses. 4 times negative 2y is negative 8y. 4 times 6 is 24. And the same thing on this side. 7 times negative 2y is negative 14y. And 7 times 6 is 42. So I get here. And now that I don't have parentheses, I can clean this thing up a little bit. You could probably do several steps at once, but what I'm going to do is I'm just going to combine like terms on both sides of the equation. What I mean by that is I got a 4 and a 24 here. Let's put those together and call it 28. I got a 4y and a negative 8y. Put those together and call them negative 4y. And then on the right, I got negative 14y. That's my only term with y's in it, so I'll just leave that alone. But I got 42 and minus 4. Put those together, you got 38. That gets me here. I'm just about done. Now I got y's on both sides of the equation. I want to move them all over to one side of the equation. So what I'm going to do is I'm going to add 14y to both sides of the equation. I will get rid of the y's on this side and make what's left with y's over here positive. So if you add 14y to this side, it's gone and you just have 38 left. If you add 14y over here, then negative 4y plus 14y leaves you with 10y. And finally, well not finally, close to finally, I want to get y all by itself. This 28 is getting in the way. Subtract 28 from both sides. You get 10y equals 10. 38 minus 28 is 10. I don't want 10y all by itself. I want y all by itself. So divide both sides by 10. You get y equals 1. Now that I know y equals 1, I can come back up here and say, well, x equals negative 2y plus 6. So therefore, maybe I'll kind of draw some arrows to show what I'm doing here. Try that again. So since x equals negative 2y plus 6, and I know that y is equal to 1, I can say x equals negative 2 times 1 plus 6. In other words, x equals negative 2 plus 6, or x equals 4. So what I get for my solution is that x is 4 and y is 1. Now we want to do that 2 more times. Once using addition and once using our graphing method. So let's see, maybe over here I'll do addition. The idea for addition is you want to take your 2 equations. So I got 4y plus x equals 2y plus 6. And I got 4 plus 4y plus 4x equals 7x minus 4. And what you want to do is kind of line these equations up. So from this equation, I got y's on both sides of the equation. Maybe I subtract 2y from both sides. If I do that, I get 2y plus x is equal to 6. You can move more pieces here if you want, but you don't have to. We can use this as our model. And what I mean by our model is we have to line these up so they're in the same position. I want to get my y's first, then my x's, then an equal sign, then the numbers, so that it matches this over here. So I want my y's first. It looks like I only have 4y, only one y term, and it's on the left-hand side of the equation. So I'll leave that alone. Then I want my x's next. I got 4x here and 7x here. So if I subtract 7x from both sides of the equation, what I'll get is this. Subtract 7x over here, that goes away. I subtract 7x over here, that gives me negative 3x. And now if I subtract 4 from both sides, I'll get 4y minus 3x is equal to negative 8. And what I want you to notice is these things now line up, right? Y's, x's equal number. Y's, x's equal number. So now what I can do is I can take those and I can line them up. I can say, let's go this way maybe. I got 2y plus x is equal to 6. And I got 4y minus 3x is equal to negative 8. And what I got to do is look at this equation and figure out what can I multiply one of my equations by, or both of them. What numbers can I multiply one or both of my equation by to make it so that when I add them up, I'll get rid of one of the variables. I think I'm making that sound worse than it is. If we take this top equation and multiply all 3 terms by negative 2, instead of 2y, I'll have negative 4y. Instead of 1x, I'll have negative 2x. And instead of 6, I'll have negative 12. And the advantage of choosing negative 2 is because now if I leave my bottom equation alone, 4y minus 3x equals negative 8, what you'll see is when I add these together, which I'm going to do in my next step, negative 4y and positive 4y will go away. And so all I'll have left is x's and numbers, which is good. I'll make this a one variable problem. Negative 4y plus 4y, those go away. Negative 2x plus negative 3x is negative 5x. Negative 12 plus negative 8 is negative 20. And so now if I divide both sides by negative 5, I get that x equals positive 4. And now that I know that x equals positive 4, I can take that and I can substitute it into any equation I want that has x's and y's in it. And that way I can figure out what y is. So I really have some freedom here. Maybe I'll choose this one. This looks relatively simple. I'll take this equation, is 2y plus x equals 6, and I'll take this value, x equals 4, and say that 2y plus 4 is equal to 6, because x is equal to 4. This equation here only has one variable, y, so I can solve for it. Subtract 4 from both sides, and you get 2y equals 2. Divide both sides by 2, you get y equals 1. So for my answer, I got y equals 1, x equals 4, which is the same thing I got up in part A. I should figure out how to separate these a little better. Try to make these solutions legible. There we go. Part A is above that weird line. Part B is below that line and above this line, which means I got to squeeze part C down here. I think I can do it. For part C, I want them both to be in y equals mx plus b form. So let's pick some colors. I guess in blue, I'll take my first equation, which was 4y plus x equals 2y plus 6. And I'll solve this for y. Subtract 2y from both sides, you get 2y plus x is equal to 6. Subtract x from both sides, you get 2y equals negative x plus 6. And finally, divide both sides by 2, you get y equals negative 1/2 x plus 3. This I can graph. Where can I graph it? Maybe I'll graph over here. So I better solve my other equation kind of over in a corner here. I got 4 plus 4y. Well, maybe I can do it somewhere better. I'll try to do it right here. 4 plus 4y equals 4x. It's not a 4. Equals 4x. Shoot, sorry, I wrote the wrong equation. I'm trying to copy this thing here. 4 plus 4y plus 4x equals 7x minus 4. Want to get into y equals mx plus b form? Subtract 4x from both sides, and you get 4 plus 4y equals 3x minus 4. Subtract 4 from both sides, you get 4y equals 3x minus 8. Finally, divide both sides by 4, you get y equals 3/4 x minus 2. And so now what I can do is I can graph these two equations and figure out where the lines cross, and that will be my solution. So let's see, to graph the blue line, I got a y-intercept of positive 3. 1, 2, 3. Means it goes through this point right here. And I have a slope of negative 1/2. So that means it goes down 1 every time it goes right 2. 3, 4, 5. So if I go down 1 and right 2, I get right here. If you want to do it again, you go down 1 and right 2, you'll get right here. Down 1 and right 2, you'll be over here. In other words, the solutions to that blue equation are all the points that fall on that line right there. Similarly, the red equation, the y-intercept is negative 2. Let's go down 2 and put a little dot right here. And the slope is 3/4. So every time I go up by 3, I go right by 4. 1, 2, 3. 1, 2, 3, 4. There you go. That's convenient. Those are the solutions to my red equation. As you can see, there's one point in here that is a solution to both the red and the blue equation. That point right there has an x-coordinate of 4 and a y-coordinate of 1. So it's at the point 4, 1. In other words, x equals 4, y equals 1, which is the exact same thing I got up here and the exact same thing I got up here. So there's 3 different ways you can solve this system of linear equations. No matter how you do it, you end up with the same solution, that when x equals 4 and y equals 1, we satisfy both equations at the same time.